Alrighty, kiddos. Today's the day we finally get to go over pressure vessel design, how to do it, how to draw it, and most importantly, how to do the analysis later on. But I figured I might as well take you and go through exactly how I made something like this from scratch, from the top essentially. And then later on, I'll show you guys how to add these flanges on top and run static analysis on the tank itself. And so this is all going to be done assuming that you do know the amount of fluid that's going to be in the tank. You already know the rough dimensions. You already know roughly what diameter you want and what kind of end caps we're going to be using and all that. We've already determined all of this through the Base 11 project and through a lot of math and calculations. So if you're curious about that, let me know, and I might make a video or point you in the direction of a document showing you exactly how to do that. But it was a cross effort between propulsion structures and some help from the other engineers on the team. But we were able to figure out some basic dimensions of the tanks, and that's what you were able to see in this other document right here, is the resulting tank from all that work. But I do know that we have a few members on the structures team that are going to be needing to do some of their own analysis or just want to learn more. So I kind of just want to go through here and show you guys how to do that from the top essentially. Alright guys, so fast forward 30 minutes when everything is done. I realize now that there's actually a much better and simpler way of designing this entire tank. It could be done in like three steps or 4 steps. So I'm actually just gonna go ahead and redo this entire thing, and I'll show you, and I'll kind of start from scratch again. So I'll save you the pain and the suffering of that other video because that was getting kind of long. Okay, so first of all, let me go ahead. Get started sketching on the front plane, and let me define some things for you. So the tank itself is going to need to hold around 173 liters of Jet A at approximately chamber pressure, pressure vessel chamber of 20 bar, which is I think around 2 megapascals. So based on some tank calculations, based on the volume of the liters that it can hold, at that pressure and at a certain temperature, we were able to come up with a certain height and certain height based on a certain radius, essentially inner radius. And so that gave us a thickness and a height of the tank. So right now for the Jet A, we are looking right around 63 inches in height total, including the end caps. So that's including the end cap, the cylindrical section, and the other end cap. So 63 is going to be our overall height, and we also know that we were basing these calculations off of a 7 inches. That's the outer diameter of the vehicle. We want 14 inches in diameter total, so radius of 7, and we're going to make another center line. No, you know what? We're going to base it off of this. And we're going to do, this is based off a thickness of 0.1875 inches. And what we're going to do now is we're going to make a line on the outside. So what I'm planning on doing is making the shell and the tank dome in one sketch, having all the measurements laid out so then we can edit them if need be, and having everything offset by a certain thickness, essentially. Or at least that's the idea. And I know that based on the ellipse of the tank domes that we're choosing from a ASME manufacturer, that it's going to be somewhere around 4 inches high by 7 inches wide. So then from there I can make an ellipse oops, I should probably make a center line. But from here, I can pretty much go ahead and define the ellipse of the vehicle. Ooh, nope, I gotta do it the other way. I gotta do total height, total width. And then I can always use the offset button and make a offset the same thickness as the rest of the dome, or the rest of the vehicle. So now this is where I can do a lot more than what I did last time. Because I can also add the cutout in the top of the tank, and I can add the flange and slash the little nub that the flange can get welded to. I can add that all in one drawing. So I'm going to go ahead and do that. So to get started, I'm going to make a center line on the top surface over here. I don't really know the top thickness. I don't really know the diameter. I think for the test stand we're using 2-inch flanges, but the thing is those are really heavy duty and big. So the thing is we're going to be running piping maybe around 1 inch. So I'm thinking maybe a flange, maybe an inch and a half might work. So I'm just going to make this 0.75. And then I'm going to cut this down into this guy. And it's going to go up. And it's cool because I'm going to actually be able to add a fillet directly in with a sketch. And again, I don't really know how big this is supposed to be either. But essentially this is going to have a thickness of its own. I don't know the thickness of this either. This is what we'll be able to tell in SolidWorks when we add the flanges and the piping and the routings. It has a smart detector, and it will be able to tell you exactly what size diameters and things like that you'll need, and then you can use that to edit these values once you know what they are. I'm just going kind of off of what I remember for the test stand. But essentially this is what we're going to want, is we're going to trim this. This is going to go straight down. And then everything else is going to be cut away. And then I'm just going to go ahead and make sure that this is smart dimensioned again. Alright, so what I'm going to go ahead and do is actually mirror this using the sketch tool right here, so I don't have to go ahead and redo that. Oh, actually, I'm going to add the fillet real quick. So to do that, go to Sketch Fillet. It's right here in your sketch tree, or sketch window. So select your 2 lines, and then it just, depending on the radius you want, it just places it. It's pretty awesome. I'm just going to go with a standard 0.1. Yes. Okay, now I can mirror. So in your top window up here, if you go to Mirror Entities, select your line, and then make sure to select the sketches that you want. Sometimes this can take a while, because especially if you have a lot of points. Okay, and that should, yeah, make sure it mirrors everything, and boom, you're good. And so now if you edit that top side, everything down here will change the same. So now all you have to do is edit this if you know that this is going to change, and edit the height and the thickness. So it'll be really easy to change on later. So now I'm probably just going to get rid of this line because we don't need that, and we don't need, oh, it got rid of it. Yeah, smart, right? So now I'm going to go to Revolve Base, and I'm going to select, remember this dashed line we made in the beginning? I'm going to select that, and select contours. It kind of already gave me a guess of what I wanted, but since that's definitely what I want, select it, and then hit Revolve. And just like that, in one feature, you pretty much get the same as pretty much all the way up to here. So just be smart about your decisions, essentially. And as you can see, I'm not always. So from here, this is where we're going to want to pretty much do the same steps as last time, and I'll probably continue the video from there. I'm just going to chop this section into there. Save you guys a whole bunch of time, but that's the fast and easy way to do it. And then from here, pretty much we're just going to add the valve, the little NPT valve thing here, and then do the analysis. So I'll see you guys for that. Peace. I'm going to go back here, delete this mirror, and then I'm just going to mirror this body. Well, actually, before I do that, I'm going to go ahead and add that extra NPT connection valve thing that I wanted. So to do that, I'm just going to go top plane, sketch on this plane right here. And I don't necessarily know if it matters too much on where it is. I'm no pressure vessel expert by any means. So I'm just going to go ahead and put it at 4 over directly 90 degrees to the east, I guess. And then what we're going to do is alright, let me think about this a little bit, and then I'll be right back. Alright, got it done. So essentially, just to kind of go over what I did, I added this little nub right here, which we're then going to cut away some material from to add an MPT kind of valve right here. But what I ended up having to do in order to get it in the angle and essentially placement I wanted of being normal to this surface, what I had to do is create a sketch from the top view, going out to roughly where I wanted the valve to be, and then I went ahead in the front view, dropped down a line from where I wanted it to the center point, or to the concentric, or until it touched essentially the surface of the ellipse, and then from there I was able to use this point and this surface to create a reference geometry, plane number 3, that was tangent to the elliptical surface at this spot right here. So then that allowed me to create this surface right here, or extrude this surface, so then it'll be normal to the elliptical surface right here. And then from there I just did the same thing as I did before, extruded the top, extruded the bottom till it mated with this ellipse, and then filleted it. Now from here, this is where we can choose to get fancy with our connectors if we want to, or we can just decide to dig a hole into there, because there is a way in SolidWorks that we can specify that we want a 1/8 or 3/8 inch thread that gets placed into here. Otherwise, we can just cut a hole in here and make a mention in the drawing itself. Um, so I figured I might as well bring you guys in and show you the toolbox and show you guys how to do that NPT cut out, because that's actually going to be really useful, and it'll make your life easier in the drawing because then you won't have to remember it. It'll be imported directly with the whole callouts in the drawings. So let me go ahead and get everything set, and I'll see you guys when that's ready to get going. Alright, so it's actually really easy. I just went ahead and double checked to make sure that the location is where I thought it was, but yeah. So two ways you can get to this. Essentially, we're going to be using a tool called the Hole Wizard to be determining what kind of bolt and what sizing and all that, what kind of threading we need for this hole right here, or that we're going to be placing here. So what you're going to want to go do is either type in Hole Wizard into the corner, your search bar up here, or you can actually see it's right here in your Features tab. So if you hit Hole Wizard, it'll pop up this menu on the left hand side, and this will tell you all different kinds of hole types that you can add, and depending on your case, you're going to want to choose, well, I guess the one that's relevant to you. For us, we're probably just going to be wanting a straight channel or a straight slot, straight tap. So we're going to hit straight tap right here, and positions. Yeah, okay, so we got everything we want because essentially we just want it to be in this circle right here. And so we're going to make sure to pick ANSI inch, straight pipe tap hole. Yeah, that's fine. Size, we can choose, I think we're going with 1/8. I'd have to double check with fluids because they're in charge of keeping that information. I'm gonna have to double check with them. But for now, let's just go ahead with 1/8 inch. We're gonna go through, or we're gonna go up to next. So that means it'll go through everything up until we reach the inside of this tank right here. And since it's hollow, oh my, come on. Since it's hollow, it'll only go up to about right here. So we want to do that. Okay. Oh boy, okay. So I need to create a point, so that's what I didn't do. So there's actually a point right here. So to do that, just follow the, as you could see what I did is I hit check, and then it told me I needed to put a point, or you can go to positions here, go 3D sketch, and then this is where your point is going to go, and as you can see, it's showing me where that 1/8 inch tap is going to be in that hole. So the thing is, I know it wants to be directly in the middle, so I already have a point for this, for the circle, so I'm just going to go ahead and select that, and it's going to go through up until that next surface, and you can see that it ends right here. So once that's good, I'm just going to hit check mark, and then boom. We got our minor diameter, major diameter, and then we got our slot cut out right there. And then as you can see over here on the side, it actually brings it up as the exact type of threading cut and the hole type we need. So that's going to be really useful, and in your drawings it'll carry over so you won't ever have to think about it again. So pretty much right here, this is where our tank is essentially done. We just need to make the second half. So to do that, I'm just going to go ahead and mirror it. So I'm going to mirror the body, this entire thing, and I'm going to mirror it about this face. And then I'm going to make sure my body is selected. Okay. Boom. There we go. So now we got our tank, 2 end caps, and we got our holes here on either side, essentially. So now this is where, this is pretty much good enough for the tank, so we can start our analysis now, and then we can always add on the flanges later. And the thing is with the flanges, those are more useful for connecting and for demonstration purposes. They don't really add anything to the structural part of the tank. So if we wanted to go ahead and actually run this analysis, we can do so right now. So let's go ahead and jump right into that window. So I'm actually going to save this, and I'm going to make a new folder for this. As you can see,